Hi guys, this is Pfizer, and in this video capture tutorial, I'm going to teach you how to convert binary numbers to other bases such as octal numbers, hexadecimal numbers, and decimal numbers. So we will be converting binary numbers to octal, hexadecimal, and decimal. Let's now have our first example. Say for example, you are given the numbers 1, 1, 0, 1, 1 in binary numbers. So how we're going to convert this to octal, hexadecimal, and decimal. Okay. So since we are already in binary, the given number is in binary, we can easily get its octal equivalent by grouping the numbers into 3 starting from the right. So we count 1, 2, 3, and then 1, 2. Then of course we apply the positional value 1, 2, 4, 1, 2. Okay, and then we add the numbers which is opposite 1. So this is 1 plus 2, that is 3, and then 1 plus 2, that is 3. So meaning to say 11011 in octal is 33. To get the hexadecimal equivalent of 11011, again we simply rewrite 11011. And then this time we are going to group the numbers into 4. So starting from the right, so we count 1, 2, 3, 4. And since we are using the 4 digits, so we are going to apply 1, 2, 4, 8, 1. So again, we add the numbers opposite 1. We have 8 plus 2, which is 10 plus 1 is 11. But we don't write 11 in hexadecimal, because 11 in hexadecimal is represented by the letter B, and then we bring down 1. So this is now the hexadecimal equivalent. Now to convert this given binary number into decimal, we can actually use the given binary digit or the octal equivalent or the hexadecimal equivalent. So I'm going to show you the three ways of converting this into its decimal equivalent. So using the given binary number 1011, we can simply get the decimal equivalent of this number using our positional value. So we have 1, 2, 4, 8, and then 16. And then we add the numbers which is opposite 1. So we have 16 plus 8, this is 24, plus 2, 26 plus 1, that is 27. So the decimal equivalent is 27. We can also use the octal equivalent by simply multiplying it with exponent of 8 raised to 0 and then 8 raised to 1. Why 8? Because we are using the octal equivalent. So any number raised to 0 is 1 times 3. We have 3. Any number raised to 1 is that number. So we have 8 plus 8 times 3. We have 24. So adding 24 plus 3, we get 27. So if you notice, this is the same as the one we get from using the binary equivalent. And lastly, we can use the hexadecimal equivalent to get the decimal conversion. So but by this time, we're going to multiply it by the exponent of 16, starting it with 16 raised to 0 and then 16 raised to 1. So 16, any number raised to 0 is 1 times B. B is 11, so we have 11. 16 raised to 1 is 16 times 1 is 16. So still we get 27. So you may use this one, the positional value, or the octal equivalent, or the hexadecimal equivalent to convert that number into its decimal equivalent. Let's have one more example. Say you are given 1, 1, 0, 0, 1, 0, 1, 0 in base 2. How are we going to convert this into its octal, hexadecimal, and decimal? So again, using the digits of the given binary number, we can easily get its octal equivalent by grouping by grouping the number into 3. So there, and then there, and then using the positional value, this is 1, 2, this is 1, this is 1 plus 2, that is 3. So we have 312 as its octal equivalent. So to get its hexadecimal, we simply again rewrite the numbers 1100, 1010. This time we are going to group it into 4, starting from the right. So we have here first group and then the second group. And then applying the positional value, we have 2 plus 8, we have 10, but 10 is A in hexadecimal. And then we have 4 plus 8, which is 12, but 12 in hexadecimal is C. So the hexadecimal equivalent is CA. To get its decimal conversion, we will be using the hexadecimal digit. So we have CA, we multiply it by exponent of 16 raised to 0 times 16 raised to 1. So we have, this is 1 times A, which is 10. Then we have 16 times 12 is 192. So the decimal equivalent is 202. Now if you want to use the octal equivalent, you can simply multiply it to exponent of 8, since we are going to use the octal. So 8 raised to 1, 8 squared. So this is 8 raised to 0 is 1 times 2 is 2. 8 raised to 1 is 8 times 1 is 8. 8 squared is 64 times 3. This is 192. So if you're going to add them, they give the same answer, which is 202. So you may use either the hexadecimal equivalent or the octal equivalent in converting it to decimal.